So we'll get into like the intricacies, but I will try to do my best to step around all the legal protections I need to do. So while I may show some tools up here, at no point can I say that Deer leverages these tools. And if I do use a tool name, it's going to be something made up. And any project names you hear on this presentation are completely made up and not real. But the scenarios are real. So it's like Unsolved Mysteries or one of those 60-minute stories. But hopefully it's something you all can connect with, especially as you start to want to figure out dependencies of dependencies of dependencies and that wonderful spider web that we all love. So let my clicker fail me because I am now on a different slide. There we go. Or it's just going to continue to fail me. So a little bit of background. So I graduated from Iowa State. I got 16 years under my belt at Deer. I was an old PO, product owner for a Deer team that John worked on. So the guy running AV, it's kind of how I get hooked into these. So got a lot of time running tools like Schmartifactory and Schmidt Hub and Shubuntu and various other Schmeliver environments. And so, and then this is my wonderful Get to Know Me page. Get to Know Me image because I was having too much fun trying to be a elite hacker in my wife's minivan. This is how most people get to know me. And I will admit, most people at Deer do not know my face because that little angry bird icon is the only rendition of me they ever see in their MS Teams or my Gravatar. So they get to encounter that first. I've held that for probably about 15 years now, so well before Teams ever existed. All right, so my team at Deer, we have this wonderful developer platform application called, we like to use the name Pickles. So we're just gonna call it the Pickles app. So give you some background, my team is primarily senior staff and senior staff engineers. So lay the landscape, there's some pretty experienced people on here that kind of know what they're doing, and that feeds into this, this from a mindset perspective of the humans. The application in itself consists of 50 plus repositories that each individually run primarily lambdas and of mixed language types. They SNS, SQS, feeding off to OpenSearch, a whole wide array of things. And the contributions to those lambdas and those repositories come through GitHub Actions and pull requests and things of that nature. So just to give you kind of a rough idea. Hopefully most of those tools are pretty common enough that I don't need to tiptoe around the names, so please don't sue me later, Dear Legal. But the pain we are experiencing is every time there was an update out in the real world, because of course, much like every other company, we leverage open source. And so every time AWS just decides to rev their SDK, or we use like Pinot in the JavaScript world, we get like something going, hey, you have a vulnerability, and it would take us a long, long time to get around to that, because that's not what we like to work on, is patching vulnerabilities. We like to work on writing new code and delivering new features to people that then can complain to us that it's broken. So we'd spend a lot of time sitting here manually updating dependencies, running npm audit, or whatever other flavor of tool that helps us keep our stuff up to date. And that got to be kind of a pain. We were spending a lot of time doing that and rather be doing other things. So that's kind of the landscape, and this is journey we've been on for quite a while, but so we wanted to try to figure out is, all right, we have these wonderful tools that tell us when there's an update. What if we were just to have it automatically give us a pull request? And what does it mean to actually merge that and have confidence? And so we have our 3-step no human in the loop process. And for anybody who understands the underpants gnome reference, you will get a good chuckle out of this. But the first one is the easy one, is automate the creation of the PR, illuminate that there is an update that needs to exist and why it's happening. That's the easy part. And then there's this magical chasm of we have no idea, and at the very end there is automated merge to prod and nothing goes wrong, and that's profit. And we're off doing other things, then we don't even need to care about the updates. And so that's the underpants gnome reference in South Park. If you haven't seen that, I would highly recommend going and asking the ChatGPT to explain it to you in your own terms, because the all-knowing, all-encompassing AI is now our friend and leader. All right, so the number one step. I'm showing just a couple because they're the two primary ones. I can't say which one we use, so from here on out, I'm going to call this Renomendabot, is whatever tool we use. But we leverage one of these tools to give us that initial PR. It's pretty easy. Most people are familiar with these. They're pretty open in the industry. So these tools feed off Mend or Renovate, Dependabot or Renovate, feed off of security databases that then also feed off of artifact repositories like npmjs.org or docker.com and various other places. And they bring awareness that, hey, one of the dependencies in your tree has an update. And I'm going to provide that. So in the case of a JavaScript world, it's going to be like, hey, I'm going to update your package lock to reflect this new update. It's going to address this vulnerability, and I'm going to run your pull request. And so, hence the easy part. These things, pretty easy to set up, especially if you're willing to just throw money at them. They're really easy to set up. So now we got problem 1 solved. Let's get the PRs. Problem 2 is created. Now we have 1,200 PRs that we need to now go manually review, wait for the build to pass, then assess, is anything actually going to break in our environments of production, and so on and so forth. And then you merge the pull request, and then you wait to see if anything actually does hit the fan, and then you go on to the second one. So we're like, all right, we spend a lot of time spending a lot of time getting the PRs. Now we're sitting here spending a lot of time just clicking buttons in GitHub, waiting for stuff, watching CloudWatch, then pressing another button, waiting another. That sounds boring as hell. I'm pretty sure I see a lot of nodding, everyone agrees. Yes, it was boring. To the point where we had this wonderful dashboard that we tried to burn down. And yes, we got to 400 open PRs at one point, and that's about as close as we ever got. Because the moment we burned down another 50, somebody ran an update and boom, we get another 100 sitting there. So it was a never-ending death march. So we were like, all right, we need a different strategy. And so we started asking this question, what would it take us just to auto-merge? Like, so both Mend or Renovate and Dependabot have capabilities of just auto-merge the pull request. Pull request is green, auto-merge it. And so we had to start taking a really solid look and a lot of very interesting conversations of, all right, if we want to make the pull request green for things we have confidence in, how do we assert confidence? And this is a pretty big statement right here, is how do you use a pull request to build confidence that the change doesn't suck? Change is not going to screw you later. This is not like a short journey. This took many months, but we started really getting down to 4 areas that we needed to improve upon. And so these are the areas that I'm going to kind of dive into a little bit at a surface. And as we go through this, if you guys laid the land, but if you guys have anybody have any questions, just feel free to pipe up, stop me. I like to jibber jabber. So these areas is dev practices, automated testing, non-prod environments, and alerting. And so we'll start cranking into these a little bit. So the dev practices, and this is the point in the presentation where I don't have a whole lot of images, so I'm sorry for the bland text. This is going to suck visually. We're already, I mean, we're all a bunch of senior software engineers or above. We're already pretty good with doing tests. I mean, we're writing some stuff, but we had gaps. It's pretty easy to write unit tests. You can crank out unit tests pretty much all day long. Where we started finding gaps was integration tests, multi-module, subsystem, end-to-end testing, where we actually start hitting real interfaces at our desks or verify that things that we were mocking are actually behaving the way that we had mocked them. And so we started realizing, oh gosh, we don't have a whole lot of confidence. I know that module works, but I have no idea that the entire Lambda can execute and execute without erring against real APIs, against real databases, against real SQSQs. And so we started driving a lot of different practices, going, okay, this is nice, we got some unit tests, our little coverage tool says we're 100% covered, but we're not really 100% covered because the coverage tool doesn't look past JavaScript or Python or whatnot. And we're like, all right, so let's take a step back. Let's start figuring out, we got some higher level stuff. Everybody kind of familiar with the testing pyramid. We need to walk up the pyramid just a little bit farther. That helped us close some of those, hey, we mocked something inappropriately gaps, increase some confidence, and built up a little bit of resilience to things in the real world that change on us. What that also illuminated is that last part. Things were changing on us without our awareness. So somebody's API would act, we obviously consume APIs from other teams. They do great jobs at being open closed and doing proper deprecation. Heck no. Somebody would change something, and we used to actually started getting earlier indications something was broken because we were running our tests at our desks. And then we'd get alerting about 5 minutes, 10 minutes later that something was hitting the fan. So really kind of helped us get early indication. The next part of this is we really started nailing down what was important to have in a code review. Getting past the conversations around linting and all these mundane things. And so we started configuring, or did I just use a weird term? We started configuring things like, hey, we want 100% code coverage. Cool. We're not just going to say it. We're going to put a check in the automation that fails the build if we don't. We are going to have clear steps that if we're going to run integration tests, everything has integration tests. And the lack of integration tests is going to fail the build. The lack of end-to-end tests fail the build. And so you have to have something that places there. Now, we still have conversations as humans on, hey, if this thing doesn't really have any end-to-end like stuff yet, what do you put in the end-to-end test? So we still have those conversations, we have those outliers, but we're acknowledging that risk as humans that, hey, we have some things. But we largely started automating, these are the clear criteria necessary for a build to go green. And then the last part is more of, here's how we had to have conversations around what our repo configurations were. And this is mostly around, we're all familiar with like branch protections in GitHub or rule sets now, and the nice little button that says I can bypass that stuff. That is something we had a few uncomfortable conversations around those settings, but we did eventually come to a conclusion that, hey, we need to have the checks. The checks are easy once we get the habits in place. And so we now use a tool. We use a tool called Safe Settings. It's an open source project. It's very much like the settings app, where we've codified a lot of these settings into another Git repo, and that way we spin up a new repository and it immediately gets all of these rules that we have put in place. So now we have good enforcement, people can't bypass it, and we start building confidence in each one of those. And so now we have automation in place for all the things the humans were checking on every one of those pull requests. And so that's from the human aspect, we had to start like building that culture, those habits that really said, hey, we've said what we want, now we have some automation to help that. This builds on that, so going beyond, starting to do that end-to-end, and I was touching on that a little bit ago. This is where we start, the end-to-end stuff I'm gonna really highlight in this part is because that's the part where we start going, hey, we have a lot of secrets, we have a lot of OAuth keys, credentials that we're having to manage. And one of the things that our team actually had to do a better job was handling our secrets. So this was something that automated testing actually helped drive better secrets management. And so previously to this, we all had this one secret that was sitting in a key pass file, and if you needed to change it, you go update that, and everyone could just reference it and go update their .env file and so on and so forth. Once we started doing this and doing way more end-to-end testing, we started saying, hey, no more shared secrets. There is a secret that our runtime environment uses, and then each developer has their own secret. And so that drove a little bit better practices around how we do that. I wouldn't say we also had some people changing on our team during this time, so we had another solid reason to roll a whole bunch of shared credentials and get rid of them. And so that was another reason. But this last one is super important because the all tests run for each PR. Through this journey, as we started saying, hey, we want the same checks to run on each pull request, we started realizing that over the course of time, we had written some great tests. But these tests were sitting in this wonderful folder called local. That wasn't getting ran by our tool. The Jaster VI tests and the JavaScript ones weren't even aware that those tests were sitting there. Because we said, hey, these are tests we run at our local bench, and they're super complicated, they're kind of flaky, and so they're not really something we want to run all the time. And we said, cool, they're super valuable because they illuminate when that thing you mocked out broke. But they are a little bit at risk of the other side, that API or that SQL database breaking you. And so we had to take a hard look at those tests and go, hey, if it's not running in the pull request, it's not valuable to have around anymore. One of the real big parts of that conversation were the majority of these tests start to atrophy. Because they weren't running, because they weren't preventing the value from going out the door, no one gave a crap. Those tests, like we started running those tests and they're like, this is using an old version of that module's interface from like 6 months ago. Because no one had actually ran the test after they committed the test in. And so it wasn't part of our automation, so it never got ran. And there was no part of our human process to go run those tests to do some smoke testing or manual checks. So we said, if it's not part of the automation, don't commit it into the repository. It's not gonna happen. And so that was a pretty big pill for a lot of our code hoarders on our team to swallow, because a lot of people get very emotionally attached to the stuff they write. I tend to be what's the guy with the sickle? The Grim Reaper, thank you. I tend to be the Grim Reaper of code. I like deleting code more than I like creating it because it's a lot easier to kill stuff. So there's a lot of people on our team that they had contributed to these tests over time, and they were really sad to see it go. And so, but a lot of those conversations spawned, we still have that need. How do we manifest that in a different way that gets ran all the time and continues to build upon this pile of confidence that we want? The next part is this non-prod environments. Of course, most people have production, the thing you're using. And if you're in the extreme in Deer, you probably have like four non-prod environments. And those teams are psychotic. And so pretty much our team has gotten down to it's prod and not prod, which we just call dev. But we don't forget that we still have this environment at our desk. And so there's still like this third like interim environment, it's the one you run at your desk. So we're kind of like, hey, these are all stepping stones to building that confidence. Obviously, you get your first injection of confidence at your desk. When you're running your test, you're making your change live, you're doing a solid red green refactor because you know you're killing it on TDD and you're making Uncle Bob so god awful happy. You get that confidence there. And then you go through a pull request and it runs all of the tests. You got good checks, all the checks pass, and it deploys to dev, and then you realize how much shit is gonna actually hit the fan. And then you're like, oh, it's not that much. I smell pretty good. And then I go to prod. And so, but each one of those hops gets you that additional confidence. So by time you get to prod, the risk of shit actually hitting the fan's pretty low. You've gotten some confidence built up. You've ran some tests at every one of those hops. And so that's pretty big. We do have some examples of people that are very cavalier and they like to go right to prod with some of their projects. All for them because they have all this confidence at their local environment. Cool. But we do really like having this dev environment sitting in between. It sanity checks all the AWS-y stuff that we have to hop in that we have yet to say, hey, we're gonna go invest in something like local stack. And so, because yes, we all know you can mock all that AWS stuff and tools like local stack, but we haven't gotten there yet. We also are starting conversations around this middle bullet for ephemeral environments. And what this would be is essentially like dev on steroids. So it'd be like, let's spin up an entire AWS account with all of its networking infrastructure for one pull request. And then when you're done, destroy that entire AWS account and all of its networking and billing infrastructure. And so Deer's not quite there yet. We have ambitions. We've been talking about that. But this would be another way of saying, hey, I don't need this environment. I can do what that fills right inside of the pull request. And that then enhances that check. Now it's even less risk that's going to get to prod because I was able to isolate a change to the entire account for just one pull request and test it out. And so that's pretty powerful. That's something that, I mean, that's kind of like the land of heaven and milk and honey. We're still, that's the direction we'd like to go, but we're on our way. And then the last part, you deployed to prod. Now you're sitting there, much like all we were, and we're just waiting for what's the error is going to start popping up in CloudWatch. And so this is something that we have started being very more diligent on, is we have a lot of alerts. So one, we want to know when one of these run a Mendabot PRs fails. So that one, we can go back and be like, you failed, we got a vulnerability we need to go do. And that tells us when the human needs to wake up and go take care of something. But also, things like CloudWatch alarms, alerts, warnings, pager notifications, all of that stuff. So if our automated dependency tool decides at 2 a.m. to get this vulnerability patched up, and all of a sudden one of our main lambdas goes down, we get paged and say, hey, you gotta come take care of this. Because really what we want to get to is it just automatically rolls back. Then we don't even get woken up. We're not quite there yet, but this is what the real cool kids are doing. We're just not that cool yet. So that kind of the red-blue deployment strategy where we can just switch back to the old thing if the new thing doesn't work, or that gradual, like Kyle from the previous DevOps meetup, like that gradual switch over, they ramped over their stuff just so they could see it not fail or fail. That's what we would like to start doing. We're not quite there yet, but we do get alerts and alarms that say, hey, something did get into prod, whatnot, and we can at least react much, much faster. And so we don't need to be sitting there anymore. Like one of our main goals is the humans are off doing other more exciting things. And so we now don't need to be sitting there watching CloudWatch. We don't need to be sitting there watching our infrastructure after this merges. We can just sit there and go, okay, I'm doing my other thing. The system will tell me if shit is hitting the fan. And if it does, now I know I need to put this down and go do that. So this last part was really big, especially for our management, to say, hey, we're cool with you turning on auto merging because we know you can react fast if it does something we don't like. And so where we are at now, and so we're on this journey. The journey's probably never going to end because we're always going to find the next thing. But we went from no PRs for dependencies to 1,200 PRs for dependencies. Now we have hundreds of those flowing through automatically every week. And so just like, I'm pretty sure by tomorrow at 8 a.m., I'll probably have about 80 emails from GitHub saying, Shmendabot just merged like this pull request. It's cool. And there were no issues. So we have a lot less gaps in our testing. We get that early feedback when stuff does hit the fan. It also helps we have a team in India that will take on the night work, and we exchange that out. And then the part that was wonderful is now that we don't get to stare at automated update PRs all day long, now we get to work on all the other mundane tasks that we get joys of, like making sure that our GitHub Actions workflows actually function, and making sure that we're moving from like node 16 to node 22 or these other things. So, but these are all things that at least we are able to take something, we're able to automate it and build confidence. The auto merging is now also having ramifications into the rest of our system going, hey, if a human comes and opens a pull request, how much do we need to do to auto merge that? And that's a very interesting conversation we're in right now. So if at some point I have information on that, because we're literally in the midst of those wonderful lessons learned and having those uncomfortable conversations around, well, what does it mean to have 2 spaces versus 4 spaces and all those wonderful linting things? I'll bring that back, but that's kind of where we're at. So. So feel free to hammer me with whatever questions you guys have. So go for it.
So that sounds like a lot of tests. How long are they running when you merge in a pull request? How long will the window of time take?
Solid question. So the question is, yeah, lot of tests, and you're not wrong. A lot of tests. How long does it take to run all of these and kind of get that green thumbs up, we're cool to merge? It can vary. I think probably our shortest thing is the shortest set of tests. I'm not gonna lie, it probably takes longer to install the node dependencies than it does to run our tests, because node installs the world. But it can range between like 30 seconds and something that's running a lot of end-to-end tests, especially things that hit like a SQL database. I think our longest running one takes maybe about 2.5 minutes. And so it's nowhere close to like what I know of other ecosystems that have a ton of databases, a ton of like interactions with APIs. Our stuff is not like a front end, so either it's just more back end data mining, and so it's a lot of microservice lambdas. So each little bit is pretty small, and so that helps us out where each lambda has its role in the system, and so we're only having to run. Can that lambda handle a message, process it, and not fail? And will it? And then we do things like data consumer producer contract testing. Like, hey, it can accept a message with all of these things. What does it do when it doesn't have those things? What does it output? And then do those inputs and outputs of the black box match? So we do some of that as well. We've gotten bit in this journey by something changing our data contract without knowing, and those lead to much more fun conversations because it could be you change that data that you're outputting, and then 3 components downstream fail, and it's like, why did that fail? Oh, it's because that thing way upstream of it changed something that it relies upon, and so a lot of this journey illuminated that because that happened to us, and so it elevated that importance of those really wrapping more tests around the black box that is the thing you're developing.
So is it fair to say that like if you get a dependency update that's auto-merged in, it's actually affecting multiple repos because they all have to get that same fix and they're all building.
Yep. So, I mean, I can't show you my email or my GitHub history, but yeah, it's, and we have some common ones. I think it also has helped because we have a couple libraries that we create for our own purposes. And when we have, say, a dependency of that library get brought in. So, I mean, our system interacts with GitHub, so we use OctoKit in the JavaScript world. Well, our library has that OctoKit dependency. OctoKit gets updated. Our library updates. Our library then publishes out. Now we have 50 repositories that all need to have a library update. And we're like, oh, every time we publish this library, we had to go like, it's the whole like, we are both the consumer and the producer of the library. So we had to, there was a big planning event. It was very expensive. And now it's, oh, just let the dependency tool take care of it. Let our tests. So now putting something into a library is much, much cheaper for us. It's get it out, the tests kill it. And it'll let us know if something we didn't get caught. That also gives us that lesson learned. Like if something does get caught downstream, we missed something in a test. We missed a situation that we should have caught. And that every time that happens or we get an alert from production, we're bringing that back into the component that's affected and running that and going, I mean, this is the spot where I was, we have my team actually has t-shirts made for this. It's literally, do you have a failing integration test? I mean, we had enough situations where literally we had to start asking this question and one of my teammates just made shirts. So yeah, this is our motto on our team is, if you've encountered a failure, do you have a failing integration test? Did you take that thing and go reproduce it in that local environment in a test that we can now prove that when we go patch it, we go change the code, we go change the dependency, that failure goes away. And so it became our team motto enough we have it on shirts. So I had to ask permission from the guys to make sure I could show skin, i.e. my arms. So. Yeah, you're welcome. Yes, sir.
Do you track the percentage of how many PRs are able to be closed without human intervention so that you can kind of trend this over time and kind of see the fruits of the labor of having this?
Oh, I wish my Scrum Master was here to hear you say that. Kind of. I mean, we did enough to be like, how much time are we spending on it? I don't know if we actually went as far as graphing like the fail versus pass rates or things like that. It was mostly just the, we have a spot on one of our Grafana dashboards that was showing open dependency update PRs. And when it went to 4 digits, we wanted it back down to 3 digits. I think it's 2 digits right now. And most of those are because we did something stupid. Or it's jumping like a major version of a dependency. Those usually, if you're doing good semantic versioning, those break your interfaces. And so those are the ones that catch us. But I'm sure that the data exists. We would just need to make it pretty. But yeah.
How often do those major versions get you? Because you're getting like 100 PR. You set up 100 PRs per day.
Per week.
Per week.
Per week. Yeah. So hundreds of PRs. I would say, at least in this week, it depends on how active the open source projects are. They're our main source, but like I just checked right before, I think we got like 130 this week so far. And this is Memorial Day week, so I mean, people have been pretty, not that everything comes from the US, but it's been pretty active. And so, yeah.
Just, you're kind of talking about a paradigm shift. Instead of looking at every single PR that would have gone green and along with the ones that would be red, you just let all the green ones go by, no effort involved, and you just concentrate on the red stuff.
Pretty much.
That requires it.
Yeah, so John, our guy in the back room, was kind of illuminating the paradigm shift that happened. So yes, I mean, the PRs were green before, but we also had that false positives of something really was failing, but it didn't fail the PR. And then we had the false negatives of random things that would fail, but were really okay, like flaky tests, all that stuff that loves to plague feedback. And so it was really like, what did we need to do in the realm of automation to build the human confidence? Because automation doesn't get nervous, the humans get nervous, and they don't want to be caught with failures all the way in their production ecosystem. They don't want to be woken up in the middle of the night because something got merged. So there was a lot of like, hey, what gates need to be put in place, what protections? And that was a lot of that. And I mean, the humans having practices that support that strategy is pretty big too. So. Sorry, I don't know if I actually answered your question. I'm still spinning on that. So I'm like.
Yeah, I was like wondering how many times you have to like go in and actually like for like major version updates, or you have to actually go in manually instead of just being automated.
I think it's still there's still a human nervousness around major version updates on our team, so it's not like a functional thing. But for example, one that I was just dealing with earlier this week was we were bumping the version of the OpenSearch JavaScript library we use, and it was going from 2.x to 3.x. It didn't actually cause any test failures, but we have our dependency management tool set to not auto merge major version bumps. It's just because those are expected to be breaking changes, and they're kind of shepherded with a little more pomp and circumstance. They also happen less frequently, and so I think it's a cost we're okay with right now, if that makes sense.
Yeah.
Yeah, like, I mean, we're not bouncing from like 20 or node like 18 to 20 or 20 to 22, but we might be going like 22.0.1 to 22.0.2, and that won't freak anybody out. But yeah, the one that I know that we have like some of them that we have open right now is like the AWS SDK. I think it's Mox just went from like V5 to V6 in like the last month or two, and so we have open PR sitting there for that. But we've planned that work out. So we see that like slew of new PRs get opened, and it's like, all right, it's not auto merging, it's because it's a major version bump. So.
Did you have to go through like update from V2, the AWS SDK V2 to 3 while you had this system on?
That was, I think that happened maybe at the start of our like journey of can we auto merge? So I think I remember it, but yeah, I think we've moved that. I know the one that's actually breaking us right now, it's not even JavaScript, it's our Terraform provider for AWS actually like is breaking our Terraform, so it stops.
The one for local files?
Maybe. This would be their like AWS Terraform provider. So, like, yeah, I just know it breaks our Terraform because it has some things about resource groups that we're using a format they deprecated. I guess they've been trying to deprecate it for a while and we just never saw it. So, yeah. And then occasionally we get caught with things like, you get dependency management for your actual code, but you also get dependency management for your GitHub Actions workflows, your Docker files, all that stuff. And one of them that caught us was that we still can't merge in is like the upload artifact, download artifact actions, and GitHub Actions doesn't work with GitHub Enterprise Server. V3 is the last one we can use. V4 requires GitHub Enterprise Cloud or github.com. And we're on a hosted GitHub instance. So we can't update to the latest one. And we won't ever be able to be. So we have to lock in at V3 and just close the pull request and acknowledge we're never going to be able to take it. So those are all like decisions that humans have to make to do that. And we have to spend time doing that. But once you find one like that GitHub Actions one, it's like, hey, we know we're never going to do that. It's pretty easy. I can search for that pull request name and just start clicking close in a lot of places. Because once we ascertain one, it's usually the same pattern happens over and over again. And we're able to say, hey, if we fix it, cool, we can go fix it in these 10 other places really fast and get the test to green. The rub is in our dependency tool, once a human interacts like with that branch is tainted. It will not auto merge it. Now it's a human branch, and we have to take ownership over it. So, yeah.
Have you thought of setting up bulk actions for the bot, like this dependency is bad, close all of them, or vice versa, this one needs to go in if it's green merge it?
We thought about it. We thought also about commonizing some of those dependencies. A lot of the common ones, not because we have like a library that needs them. It's mostly just a common choke point to decrease that. But yeah, things like Octaherd. Have you ever tool called Octaherd? It's like a CLI tool where I can say, I want this code ran across these all the repositories in this org, and it will pull it down. It'll do it all via API. And so Octaherd's a pretty cool tool that we poked at quite a bit. Or you can just be like me, where I'm a Bash guy in the midst of JavaScript developers, so I make fun of them a lot. And I just be like, hey, you know that 300 lines of JavaScript, I just did that in 20 lines of Bash, haha. And so I do that occasionally on them. But yeah, trying to do it's starting to become a term in the community or a term in the world called fleet management. This is kind of like a surface scratch of that. Is like what you're talking about is another one. Is I have a change I want to make, and I need to make it across 200 repositories, 300 repositories, 20,000 repositories. How do I do that? Because the more that repository count, the more expensive it becomes, and that is a whole nother beast of crazy. And, I mean, you feel it at like 5 repositories, 10 repositories. It becomes cumbersome when you start getting in the triple to 4-digit or 5-digit numbers, and that's just like, especially no one wants to pay for it unless it gets automated. So that's where we were trying to do a lot of that here, and it builds. Like, we can make a change like that. Go for it.
What's keeping you from automated buildbacks?
Ooh. Time. Honestly, it's time. It's also nobody's yelling at us for it yet other than ourselves. And so right now I'd say our customers are, because we treat ourselves as mission critical. So we try to respond to failures like we wake up in the middle of the night if something fails or whatnot, but we don't have the necessary like business requirements that say you need to have like 5 nines of uptime, or things like soft rollouts. You need like that kind of stuff where we could be down for a few minutes and no one's going to care. If we're down for much more than that, then we're going to care. So it's about the time. Like, it hasn't bordered on, can we wake a human up and revert a pull request, ascertain what's going on, revert a pull request. Can we do all that inside of an hour? Cool. Is the business cool with that? They're still cool with that. And so if that ever changes, then now we have a business need. The business then fronts up, hey, we're going to pay for that to change that decision. I think that's the biggest one. Yeah. So, and obviously it takes it takes effort and time to set up something like that. And it also, like, that has ramifications not just in, hey, our style or culture of our team, which honestly is the easy part because we're all bought in on blue-green. We'd love to do it. It also has ramifications in how much you're going to spend on your cloud costs and things like that, because you're talking about basically not just like one environment. You have 2 environments running in parallel in prod that you spin up, spin down, you switch, like how many lambdas are getting spun up for what, and so on and so forth. And then how do you rectify that in your logging so you know, is this the one that we just rolled or the existing one? All that stuff has to be thought out. And we're just not there yet. So we get the business start yelling at us though. Oh, we'll pivot. So we would love that. So our team tends to be artisans of deferment. So we'll defer things as long as possible. Not that doesn't scratch the itch of every college kid who procrastinates, but it definitely, we wait for the business to start yelling at us about stuff. We do have hills where we're willing to die on. Like, we as software craftsmen don't want to let certain things happen. But stuff like that, where it's, hey, that has a cost beyond just our own time. It has a business cost that comes out. We kind of need them to yell at us for that. We got 7 minutes. We can just all start piling pizza into our gullet. So, well, if you guys have any questions, hit me up afterwards. I think I'm really excited for the next DevOps one where the lightning talks about languages, or because that gives me an opportunity to talk more shit about JavaScript and just promote Python and Bash like things. So I'm really excited. So come for that, please do. I'm excited to see all the differing viewpoints. So thanks again.
Test.